Okay, this is the fifth lecture I've had to give today on this Saturday. So hopefully this is going to be the relatively short one. All right, so what you all have is you should be given this sheet of paper right here. We're going to work through this so you can get an idea of how this is going to play out. On the assignment from yesterday, hopefully you don't have any problems with that. Let me give you a hint. On problem number 10, both answers are around 10. On problem 13, because that's in series, what you want to do on that one is go like 1 over x plus 1 over x plus 1 over x. And then because of those are all in series, and that's going to equal like 1 over 30. And then that's how you're going to find that value. You just have to keep track if those are in series or if those are in parallel. Okay, so here's what we've got. I've kind of got this worked out in steps. So what you have here is a 30 volt battery. Okay, so this is going to be 30 volts. I have no idea what these are, why these are here. So we're going to, in this situation, we're going to have all three of these are going to be 10 ohm resistors. So what you want to figure out is like the equivalence. Oh, okay, right. So these two are going to be 1 over 10 plus 1 over 10, and then the inverse of that, which gets you 5. So having two 10 ohm resistors in parallel is like having one single 5 ohm resistor. Then, here's the trick. Then you have a 5 ohm resistor that's in series with a 10 ohm resistor. So that whole thing together, those three, 2 in parallel, 1 in series, is like having one big massive 15 ohm resistor. Okay, so when you look at this in terms of voltage, the battery is 30. So when you look at the voltage drop, okay, so let's go to the simulation. So the current is going to be 2 amps. And the reason that that's 2 amps is because you've got a 30 volt battery. It's like having one 15 ohm resistor. So if you take 30 volts and divide that by the 15 ohms, that's how you're going to get your 2 amps. Now, the voltage drop across that 10 ohm resistor, wait for it, is going to be 20 volts because of the fact that it's like, this is like fish with the Skittles. So if you look at this in terms of measuring that voltage drop, if you vert it up, the current going through there is 2 amps. You've got a resistance of 10 ohms. You take 2 times 10, you get 20 volts. That's going to be that voltage drop across there. Now, if you measure the voltage drop across this whole thing, okay, start to finish, oddly enough, hold on. I don't want to get anybody flipped out. You're going to get 30 volts. So the voltage drop across the entire thing is 30. But because these are in parallel, if you were to measure the voltage drop across each one, that's going to be 10 volts. And here's the reason why. Because if you look at the current, that's 1 amp. So you've got a 2 amp coming into here, okay? That's going to get split evenly with 10 ohms, 10 ohms. They're each going to carry half the current. Each one's going to be 1 amp. If you vert it up and you take 1 amp times 10 ohm resistor, you're going to get 10 volts. So each one of these is going to drop 10 volts, okay? That's going to get 20. Total voltage drop is going to be 30. So that one's relatively simple, but here's what I want you to see. The first thing that you have to be able to do on this chart, okay, so let me get that chart pulled up. So the voltage drop across, oh my gosh, I don't have to redo all my calculations. Give me a second. There it is. I just had it. So the voltage drop across this one here is going to be 20 volts. Okay? The current going through that one is going to be 2 amps, because that's like taking those 30 volts, dividing it by a 15 ohm resistor, because these two values are here like 5. That's 10. So the total resistance is 15 ohms. Because these two in parallel are like having one 5 ohm resistor plus the 10, boom, there you are at 15. So the voltage drop across the other ones is going to be 10 volts and 10 volts. Okay? Now, each one of those is going to be 1 amp, 1 amp. So when you get a problem like this, the first thing that you need to do is find the equivalent resistance of all of the resistors. That's 15. Take 30 divided by 15. Now you know the current that's in the entire system, which is going to be 2 amps. That 2 amps is going to get split 1 and 1 because they both have the same resistance. Easy peasy, we're off to the races. Now, where it gets more complicated. But wait, yes, it does get more complicated. I know you'll find that shocking. And Morella's going, oh, Mr. Burkamp, really? Yes, I'm going to make it more complicated. Call it tough love. Now, with this one, so now we're going to move down to this one. So now we're going to keep that as a 10 ohm resistor, okay? But now we're going to make this a 5 ohm, and we're going to make this one a 20 ohms. Now it's not symmetrical, so now we're going to have a 5, a 10, and a 20. So I'm going to go back to this system. I'm going to change that to 5 ohms. I'm going to change that one to just can't quite get it. 20 ohms, okay? And my current's 2.14, so I got a 10, a 5, and a 20. So, here's the story. So when you do this, oh, wrong one. So if you look at the equivalence of this, so this is like taking, to find the equivalence of this, that's 1 over 5 plus 1 over 20. Take the inverse of that, because these two here, this 5 and this 20, are in parallel. You do the math, you get 4 ohms. Then you've got that 10 ohm out here, that's in series. So it's like 10 and a 4, you get an equivalent of 14 ohms. So now we got a total equivalence of 14 ohms. So if you take those 30 volts and you divide that by the 14 ohms, you get 2.14 amps. Okay? So if we go back to the program, that's what this is showing, 2.14 amps. Now, that 2.14 amps is going to get split. Now, how do we handle that one? That's where it gets a little bit dodgy. By the way, before I forget, when you all open up this program, it's a weird deal. There's 2 different versions of this FET simulation. So what you're going to do is you're going to get your Chromebooks out when you do the lab, type in FET circuit builder. Make sure that you get one that has a contactless amp meter, because there's 2 versions of this. Don't get the one that just has this old school one, because that one it's a pain, because you have to actually like break the circuit and put it in there. Make sure that when you do this, pick one, it'll say like DC circuit builder. Make sure that you pick one that has this contactless ammeter, or otherwise this lab takes a lot longer because you always have to break the circuits and it's a pain. Now, here's the mathematical trick to figure out this current. So what you want to do, you got to remember the 2.14, okay? Remember that 2.14. So now, to figure out this current, it's like a ratio. So what you want to do to calculate the current going into each of these, what you're going to do is, let me get rid of this. My laptop, this thing is about to die, so I'm racing, ironically, I'm racing a dying battery. So what you want to do to find the resistance in one of those branches, the formula, and I've got this up here in the notes, right here, okay? So you take the total current in the circuit, which in this case is going to be 2.14 amps. Then 1 minus, and this is like a ratio. So you take 1 minus, in this case, the 5 ohms, and then you divide that by the total resistance in the parallel portion of this. So if you do the math here, you take 5 over 25, subtract that from 1, multiply it by 2.14. This gets you a ratio. So if you do the math here, you get 1.71 amps. And then to find the lower one, you're going to take 2.14 amps times 1 minus 20 over 25, and you're going to get 0.43 amps. Now, this is where the magic happens. Notice that these add up to 2.14, which is the total amperage in the circuit. So, when you do this, you get 1.71 and 0.43. So, look what happens. The 2.14 current is flowing into here. The lower resistance, the 5 ohms, is going to be carrying more current of 1.71. The higher resistance one is going to be carrying 0.43. Got that? Now, when you look at the voltage drop, okay? So your voltage drop, when you go to that one, but notice that the voltage drop, okay, are both 8.57. And the reason being is if you ver it up. If you ver it up, if you look at the voltage here, so this one has a higher current of 1.71 amps, but it has a lower resistance of 5 ohms. This one has a lower current of 0.43 amps, but it has a higher resistance. So notice that that voltage drop is the same across both of those. Now, if you want to look at this in terms of a bigger picture, in terms of your voltage drop, you can look at this in terms of just one entity. If you look at that as just being a 4 ohm resistor, a single 4 ohm resistor, with that 30 volts, you can also view it that way. Now, I'm rushing this because literally my battery is about to die when you look at this thing. So, you should have this sheet of paper. The lab that you're going to do is this one. So, I tell you, listen to me, listen to me, listen to me, listen to me. So help me, I will lose my mind if you all don't follow this. All calculated values, every one of them, is to the hundredths place, okay? Not to the tenths, not to the thousandths, 2 decimal places, okay? Listen to me, 2 decimal places. Count them, dose, 2 decimal, even if they're zeros, I want 2 decimal places, okay? 2 decimal places. So you're going to build this. You're going to put a 40 ohm resistor, a 10 ohm, a 20 ohm. And what you're going to do is that you're going to determine all these calculations. Don't worry about this alpha. We'll deal with that later. So right now, you're just going to build this where you have 3 resistors that are in parallel. Let me give you a hint. Here's a sequence. Take the 10 and the 20 and treat those as an equivalent resistor. Add those together. That's going to be in series. Take that equivalent resistor and then add that in parallel with the 40 ohm. And that's what's going to allow you to get that entire thing. So, you're going to go through and you're going to calculate your voltages. The idea being is that you do the math first and then you verify it with the program. Now, when you get over to section 2, at the point of the labeled alpha, okay, now you're going to remove that wire and you're going to put in a 4th resistor, and that's going to be a 5 ohm. So you're going to have a 5 and then the resisting ones. Then you're going to go through all of these calculations. When you get over here to this one is going to have an internal resistance, okay, of 2 ohms. So this is going to be a battery. you're going to have, and you can change that setting. Right now the batteries are designed to have no internal resistance. You can change that setting in the program and change that, and then this is going to be this last one. So I'm done. Please hand these out to the kids. This is going to be due on Wednesday. Yes, hopefully I'm back on Wednesday and we'll go over it. So you're going to have this, work through this. Then you're going to have the lab, work through that. There you go. My battery is dying. I will hopefully see you all tomorrow. Peace out.